Let's look for the critical points of this function and then find the nature of the critical points, whether it's a local max or local min or a saddle. To find critical points, you need to find the partial derivatives. If you differentiate by x, that's 4x cubed. When you differentiate by x, y is treated as a constant, so this will become 0. And negative 100xy, when you differentiate by x, x becomes 1, and you get negative 100y. On the other hand, if you differentiate by y, now x is treated as constant, so that's 0, with y to the fourth will be 4y cubed. And then if you differentiate this by y, it will be negative 100x, because y differentiates to 1. Now I need both of these to be equal to 0 if I want a critical point. So let's see what that gives us. Well, if I divide by 4, that's x cubed minus 25y equals to 0. And over here, this is y cubed. If I divide by 4, it's y cubed minus 25x equal to 0. Now, none of these will yield a value for x or y. Sometimes you just have the values for x and y and you have to chase what it means. But here, you don't get a conclusion from each of these equations. You only get a conclusion when you mix them together. But it's still okay, because if you think about it, these are two unknowns, x and y, and you have two equations. So technically, there should be a way to solve it. How do you solve such a thing? Well, you plug in, you solve for one of the values. So let's say you solve for y. X cubed is 25y, so that y is x cubed over 25. And then once you solve it, you plug it into the next equation, and that's going to solve the equation. So I get x cubed over 25 to the third power minus 25x equal to 0. And that means you get x to the ninth, 25 to the third, minus 25x equal to 0. Let's multiply 25 cubed because I don't like fractions. So I'm going to multiply this. And that's going to give you x to the 9 minus 25 to the fourth, x equals to 0. If you factor the x out, that's x to the 8th minus 25 to the fourth equal to 0. So either x is 0, when two things multiply to 0, it's either this one, or x to the 8 minus 25 to the fourth equal to 0. 25 is 5 squared, right? So you can write down, if you move this to the other side, it's going to be 25 to the fourth is 5 squared to the fourth, which is 5 to the 8th. So this is going to give you 5 to the 8th. Oh, so x must be 5. But not so fast. You have to be careful because this is an even power, so they could still be the same whether it's a plus 5 or negative 5. So you actually have three critical points, which is 0, 0, well, I forgot to calculate y, right? So now let's go for y. Y is x cubed over 25. So when x is 0, we get y as 0, so that 0, 0 is a critical number. When x is 5, then y would be 5 cubed divided by 25, but this is 25 times 5, right? So you get 5, so 5, 5 is the other point. And then if you plug in x equals to negative 5, you're going to get the same exact story, except that negative 5 cubed will be negative of 125, so you're going to get negative value for y. So you get this, and you get negative 5, negative 5. Okay, so we found that the critical points are 0, 0, 5, 5, and negative 5, negative 5. Okay, now let's move on to calculate the Hessian. So remember that fx is 4x cubed minus 100y. So if I want fxx, then I should differentiate this by x, where I treat y as a constant, so it will be 12x squared. Fyy is 4y cubed minus 100x differentiated by y this time, so it's going to be 12y squared. On the other hand, if you do fxy, that means you're taking this and differentiating it by y, so 4x cubed is considered a constant, and if you differentiate negative 100y, you just get negative 100. And remember that second partials commute, so it's like this. Which means that our Hessian, or the determinant of the Hessian, is 12x squared, negative 100, negative 100, and then 12y squared. And let's evaluate this. So at h at 0, 0, this will be 0 plugged in here will be 0, negative 100, negative 100, and then when you plug in 0 here, it's going to be 0. So you get negative 10,000, which is a negative number. And then 5, 5. Okay, and then we are going to plug in 5 here. 5 squared is 25. 25 times 12 will be 300 here. So when you do this minus this, it will be 90000 minus 10,000. Oh, one more zero. So it'll be 80,000, which is positive. Okay, and because 300 is fxx is 300, which is positive, we have a smiley face, and at the middle of the smiley face is the local minimum, right? So we see that 5, 5 is a local minimum. Oh, I forgot to say what this meant. If the determinant of the Hessian is negative, that means it's a saddle point. And let's just change the color. At negative 5, you actually have the same exact value because all of these are squared. So the Hessian of f would again be 80,000, and fxx is again 300. So we get negative 5, negative 5 being local minimum also. So the answer is we have two local minimums, one at negative 5, negative 5, and 5, 5, and 0, 0 will be a saddle point.